Hello, my teachable students. I welcome you to our special class where we present the simplicity of the science subject. I am DFM Mike Mattis. My appreciation goes to those that are doing whatever they can within their ability to encourage me on what I'm doing. God bless you. Your labor will not be in vain. And if you happen to be one of my friends on this page, please be the type that encourages with your like, comment, and share. God bless you. And for those that are yet to be following the teaching, please do. The last time I solved a problem we have under angle of elevation. Today I'll be solving a harder problem under same topic, angle of elevation. Now, if today is the first time of watching our video, please go to our previous video and watch how I solve problems we have under trigonometric ratio by clicking the link we have in the comment section. All right, so let's go to the problem we have in example 8 as I read out the question. C is the foot of a tower CD standing on a horizontal plane, and ABC is a straight line in the plane. The angles of elevation of D from A and B are 27 degree and 46 degree respectively. Full stop. If the line AB is equal to 30 meters, calculate the line CD correct to the nearest meters. Now, like I told you then, okay, in the last video that I did, I said whenever angle of elevation is mentioned, it means the observer is looking up to an object. It means the object is above the highest level of the observer. So the observer have to look up to see the object up there. And here we have two angles of elevation, okay, which are 27 degree and 46 degree. So we can as well assume that there are two observers here. And the two of them, they are looking at the same object. And the object is D, all right? Or we can say there's an object at D. Okay, and I told you then in our last video under this topic that whenever angle of elevation is mentioned, it means there is an observer or observers, and there's an object that is far above the observer's eyes. Okay, so angle of elevation has to do with looking up to an object that is above the eyes level. So here we have two observers looking up to an object above their highest level, and the object is D itself, or an object is at D. Do you understand? So here we have two different angles of elevation. If you have an object that is up above your eyes level and you are far away from the object, you just have to lift your eyes a bit up to see the object. It means small angle of elevation. But if you are close to that object that is above your eyes level, you will have to lift the eyes more to see the object. It means a bigger angle of elevation. So here, the one with 27 degree is far away from the object, and the one with angle 46 degree is closer to the object, and the two of them, they are looking at the same object at D. So like I told you then again in our last video under this topic, I said just draw a right angle triangle out under angles of elevation, and when you do, you cannot put in your values in their right places. But here, since we have two angles of elevation, you will have to draw a bigger right angle triangle. Then inside, you now introduce another angle of elevation. Now look at the diagram I have here. So in this diagram, we have the first one, the bigger one, is ACD. Now why A here? Because one of the observers is here and it's looking up. Another question is that why C here and D here? They said C is the foot of the tower, all right, and D, from the question they said angles of elevation of D, so that D is up. So we have A, C, D. So you now introduce another observer. Okay, that observer too is looking at D, object at D. So from that D, you now draw a line inside, okay, to B. All right, so that one will carry angle of 46 degree because it's closer to that object D. And that A, 27 degree, because it's far away from the object D. Do you understand? The question says we should calculate line CD. The line CD here happens to be the height of the tower. All right. So to do that, okay, luckily they gave us the distance between the two observers, line AB, to be what, 30 meters. All right. So to solve this, like I used to say, that split your triangle out. Here we have three triangles, but what we need is right angle triangle, and right angle exists at C. So if you are bringing out your triangle, okay, it has to be connected with C. All right. So the first one I brought out is the big one, which is ACD. We have that here. So we have the C here. So that made this one a right angle triangle because we have angle C here, which is 90 degrees. The second one is the one inside, which is BCD. So we have BCD here. All right. Of course, C is also here. And I told you then that when you split out triangle from a shape, there will be a common side. What is the common side here? Line CD. Line CD. And that place is not given. So what do? We indicate a letter. And here I put X, okay, for the line CD. So we have X there, we have X there, because that is the common side. All right. Now, if you look at the down part, they give us the distance between AB, but we are not given distance between BC. And that BC is very important because it's connected to the right angle. So what you do, we introduce another letter, which I did. I put Y here. You cannot use X again because X stands for the line CD. So what I put here now is Y. So if AB is 30 meters and BC is Y, of course, in meters. So to get the whole length A to C, because C is the right angle, we will have to add up the 30 to Y. That gave us 30 plus Y. That's what you have here. All right. So if you look at the two shapes now, you discover that we only have one known value, only one known value, which is in the first right angle triangle, we have 27 degrees, a known value. Now this one is not a known value. Why? We are adding 30 to unknown value. So that makes everything here unknown value. So the only known value we have here is 27 degrees. And the second right angle triangle too really have one known value, which is what? 46. It means you can start with anyone. And to start with anyone, like I said, you first name the side. So the naming now, X is opposite. Y is facing 27 degrees. And the hypotenuse is line AD, even though we don't need it, but that remains the hypotenuse. So if you have the opposite, you have the hypotenuse, automatically line AC becomes what? The adjacent. So X is O, 30 plus Y is A. So OA, it is TOA, that is tan. So we have tan 27 degrees is equal to opposite, which is X, over 30 plus Y, which is what? Adjacent. All right. So because what you have here is not special angles, you have to use your calculator or statistical table. So tan 27 degrees is 0.5095. All right. You can make it over 1 so that it becomes fraction. Is equal to what? X over 30 plus Y. So when you cross multiply, because we are dealing with equation here, X will multiply by 1, we have this. And this 0.5095 will multiply by these two terms. So I put the two terms in bracket. That makes it equation 1. If you like, you can open the bracket, but I decide to leave it like this. Okay? So that makes it what? Equation 1. Why equation 1? We have two unknowns, X and Y. Now, in the second right angle triangle, let us name the side. The X is opposite. Y is facing 46 degrees. The hypotenuse is BD because it's facing the right angle, even though we don't need it, but that remains what? The hypotenuse. Then, if you have opposite hypotenuse, then and BC becomes what? The adjacent. So X is opposite, which is O. A is adjacent, which is A. So OA is also what? TOA. That is tan. So tan 46 degrees is equal to what? X over Y. All right. Now, tan 46 degrees, okay, with the use of calculator or statistical table, that gives us 1.036. Put 1 under it to make it a fraction. It's equal to what? X over Y. So when you cross multiply, 1 times X, that gives us X. Then this is multiplied by Y. We have this. So equation 2. So if you look at equation 1 and equation 2, the subject of the formula in each of them is what? Is X. And since this X, okay, came from the same shape, then the X are the same thing. They're equal. So we can equate the X. All right. So in equating X, we say S is equal to what? X. So the value of X in the first right angle triangle is what you have here is equal to the value of S in the second right angle triangle. That's what you have here. So now you cannot open the bracket. All right. So what you have here, multiply what you have inside the bracket here. So this multiply 30, we have it here, and it's also multiply y, we have it here. It's equal to what you have on the right hand side. Now if you look at it here, we have 3 terms, and out of the 3 terms, 2 are like terms. What are the like terms there? The one that come with y. So I will now shift this one that is on the left with y to the right. Okay, so it was plus before, then it became what? Minus. So you take away, you end up with this value here. So now to find the value of y alone, because what you have in the diagram here is y alone, not 0.5265y. So you have to divide both sides by what is attached to the y here. Divide both sides by this. So when you do that, y will be left alone. So when this is divided by what you have here, you have what? 29.031. Okay, that is the value of y, of course, in meters. All right, but what you are looking for is the height of the tower, which is CD. All right, so in that case, you don't need to approximate this y. Leave it like this in decimal number. Then you now use this y to get the value of s. You can use equation 1 or equation 2, but the best one to use is what? Is equation 2, because in equation 2, what you just have is s is equal to 1.036y. So just replace the value of y with what you have here. So when that is done, you have this answer for x. Okay, so in meters, this one is in 3 decimal places, but they said to the nearest meter, they cannot approximate. All right, because that is the answer. So to the nearest meter means to whole number. So the whole number here is 30. The next number after 30 is 0. It's not up to 5. So just round it down to 0. So just ignore them. So our answer is 30 meters. So the height or the line CD is what? 30 meters to the nearest meters. I hope you understand how I solve this problem we have in example 8. So when you have two observers with different angles of elevation, the one with smaller angle of elevation, okay, will be far away from the object it is looking at, and the one with bigger angle of elevation will be closer to the object is looking at. Let's meet in our next video. I am DFM Mike Mattis. Thank you and bye for now.